Dr. Zhong was our CIE former president, and we graduated from the same university. So there's two loop put us together. Okay, now is your turn, Dr. Zhong.
Okay, thank you, Jesse, for your introduction. Good afternoon, everyone. I'm very pleased to join you for this discussion on how oil and gas industry can work with the rest of society to combat global warming through reducing our carbon footprint. Since this is a very hot debated subject, so I want to put some disclaimer here. And basically, all the information I'm going to discuss are in public domain, and this presentation represents my personal opinion. So here is the outline. Even though I'm going to talk about oil and gas industry, actually I'm going to use Halliburton as the primary example. So I'm going to give a quick introduction of Halliburton. Now I'm going to discuss about the root cause of global warming, and then what we do about the root cause, and with some examples. So first, a video.
Conducting business in a manner that is socially and environmentally responsible.
So that's Halliburton. So now let's get into the main content. So we want to reduce carbon footprint. So then the question is, what is the root cause of global warming, right? So the prevailing one is we all see this chart in one way or another. So over the past 100 years or more, we see a steady increase of the global average temperature, especially since 1970s. But 100 years is a blink of an eye in the natural history of the Earth. Let's look at the phenomenon from a larger scale, right? We're going to look at this at a much larger time scale and look at these phenomena holistically. So here is a chart about the estimated global temperature over the last 500 million years. Before we get into details on this chart, there are a few facts here. One is the Earth was formed 4.5 billion years ago. At the start, the Earth actually was very hot during the formation stage. And then around 3.5 billion years ago, life started to appear on the Earth. Another very important time marker in the Earth's natural history is around 800 million years ago to 600 million years ago. That's when there was the first ice age on Earth. At that time, the Earth covered almost the whole globe, right? Spread it from the poles all the way to the equator. So after that, this chart shows the global temperature, average temperature after that. In this chart, the vertical axis is the global temperature, average temperature in Fahrenheit. The horizontal axis is the millions of years ago, right? And the red curves corresponds to the period where the Earth has no polar ice. And the green curves corresponds to the period where there are ices on both poles. Here, I have a circle here. That's a very important time marker in the natural history of Earth as well. That's when dinosaur appeared on Earth, right? And so the other comment I want to make here is that, look, this time scale is 500 million years, right? So, and this pointer here at the end, that's today. And you see that dot on this axis, that's 5 million years. And here is where we are. Here is where we are. And as you can see, right now, the Earth actually is much cooler than most of its natural history. Then the question is, we are talking about global warming. And you tell me the Earth is much cooler than before. So let's zoom into, instead of 500 million years, let's look at the 500,000 years. So the reason we want to look at the 500,000 years, now we actually can measure the Earth's temperature through ice cores at Antarctica. Here, the horizontal axis on the top is the depth of the ice, which corresponds to the years the ice was formed. And so there is a one-on-one correspondence there. And then the red curve corresponds to the temperature variation with respect to the average temperature of minus 56 C in Antarctica, right? And the blue curves corresponds to the CO2 concentration in the atmosphere. Here I covered the last 20,000 years. Let's look at the first 400,000 years and see what are the main features of the global temperature change. One thing we can see very clearly is it seems the Earth's temperature is going into cycle and it's repeating itself. And that cycle is around 100,000 years, if we ignore some of the fine features in the curves. The second observation is that the CO2 concentration correlates very well with the temperature variation. The third observation is that every time when the Earth's temperature reaches peak, it will, monotonically decrease. So that's the features. The question is why the cycle is 100,000 years. Second is the temperature variation and the CO2 variation, which is the cause, which is the effect. So here is the orbit of the Earth around the sun, right? So we know the Earth's orbit around the sun is in ellipse shape. And also we know, everybody knows the Earth's relation to the sun dominates the temperature on Earth, right? When we are on the certain location where in certain season, right? When it's winter, it's typically colder. When it's summer, it's typically warmer. So what I'm trying to say is the astronomical position of the Earth relative to the sun is a dominant factor of the temperature on Earth. And here, one thing maybe most people don't know is that actually the Earth's orbit is actually not always an elliptic. In fact, roughly speaking, the Earth's orbit changes from roughly a circle to an elongated ellipse in about 100,000 years. Furthermore, the Earth's axis, which is actually not perpendicular to the plane of the orbit. And the cycle from the circular orbit to the elliptic orbit is about 100,000 years. The second phenomena is that the Earth's axis is not a fixed angle to the orbit plane. It's actually varies between 22 to 25 degrees. And this change of it's called axial tilt. The cycle for the axial tilt is 41,000 years. Furthermore, this tilt is not linear, it's actually wobbling. And that wobbling is termed axial progression. And that axial progression's cycle is 22,000 years. With all these astronomical facts, which actually are calculated from Newton's mechanics, right? So those facts can explain the primary feature of the previous curve. But we know there are fine features which cannot be explained. The reason is that there are many other factors that also impact the global temperature. The one dominant factor is the sun. Any variation in sun's activity will impact the Earth's temperature. The other factor is the core, the inner core of the Earth is very hot. And any continental plates movement, especially volcanic eruption, will disrupt the cycle determined by the Earth's position relative to the sun. So with that, let's put back the last 20,000 years. When I show this, and I think many of you will find out the feature of the temperature change is substantially different from the previous cycles. Instead of continuous to decrease, it is, almost on average, is almost plateaued. And from the first chart of this section, we see it's increasing, right? Furthermore, we see that the CO2 concentration in atmosphere is well above historical high. And, it's not just a little bit, it's above the historical high by a very large margin, right? So this deviation from the natural historical pattern is caused not by natural factors. And that's how we determined that the current global warming is due to human activities. Human activities that cause excessive greenhouse gas emission. So we know that. Then the question is, that causes a problem, right? The problem is due to the temperature change is too fast, because we know previously the temperature has been much higher, but now the temperature change is too fast. Lives, plants, animals on Earth they don't have time to evolve, to adapt to the increased temperature. So the question to ourselves is, what can humans do and how? So there are 3 R's to achieve this reduced greenhouse gas emission. That is, reduce consumptions, reuse materials, and recycle waste. And these 3 R's has a decreasing impact on the Earth's greenhouse concentration, with reduced consumption to be the most impactful action. Actually, we have a very large scale, a global scale, basically man-made test last year, right? So in 2020, we have a COVID pandemic. Because of COVID pandemic, we have lockdown worldwide. We drove much less. We essentially stopped flying. Because of that, our daily carbon dioxide emission due to transportation actually in all dropped 10% compared to 2019 level. And if you look at the daily average change, the change actually was as large as 20%. So this is a clear demonstration that if we reduce our fossil fuel consumption, we can reduce CO2 emission. But we don't want to change our way of life. We still want to drive. We still want to fly to places. And so what can we do? So one proposal is to remove fossil fuel for our energy portfolio. A very specific proposal was to eliminate fossil fuel by 2050. Is that possible, right? Let's look at the facts first. Right now, this is the 2020 data. Right now, we use 11,865 megaton of oil equivalent fossil fuel every year. If we want to eliminate the fossil fuel from our energy portfolio, we have to reduce 1 megaton of oil equivalent every day. What does that mean? We need to build 1 nuclear plant every day, or we build 2,000 wind turbines every day, right? Or we install 4 million solar panels every day. So I think many of you in the audience may have drawn the conclusion as I drew here. This is practically impossible. And actually, BP Energy Outlook shows that by 2040, right, our renewable energy production will double than the 2020 level. But it's still a quarter of the total energy portfolio. Since we want to maintain our way of life, want to maintain our quality of life, so fossil fuel has to stay with us for a long time. So what can we do, right? The energy industry, especially oil and gas industry. So we are working with the rest of the society, try to reduce our, carbon footprint, right? So I'm going to use Halliburton as the example again. So here I'm going to show a short video from Halliburton on Earth Day.
Today, we celebrate Earth Day and recognize the ongoing role our company and industry play in lowering emissions, improving energy efficiency.
Allan, can you turn out the volume?
Okay. This is internet. So I was trying to turn on include the computer sound. If you can help to do that, then this will do it. Include the computer sound.
Moving to a lower carbon energy future is essential.
Could you start the video from beginning?
Yeah, let's do that.
We are mitigating the impacts of climate change through innovation and collaboration employees to achieve these targets. On Earth Day, we ask you to look at your daily activities and think about where you can make changes to reduce energy use. I hope you'll join us as we celebrate Earth Day today and every day.
So, so that's the Halliburton's actions planned and taken right now. And here I'm going to give you a few examples on how we reduce, reuse, and recycle. Since we are, short on time, I'm going to go this rather quickly. So first, we're going to reduce our material and energy consumptions in our product development through virtual testing, numerical design optimization, and innovation, right? So, so our products are used in the clean energy production as well. And this is one of these innovations we use, which can be used to advance clean energy solutions in geothermal well constructions. The other one is a revolutionary product our company invented. It's an autonomous inflow control device, which uses fluid dynamics principles to autonomously control the fluid flow in the well. Basically, it helps to increase oil production and keep the polluted water production down. And that's how we can reduce our energy. One way for us to reduce our energy, greenhouse gas emission and CO2 carbon footprint down. For the reuse, many of you know, we have millions of wells, obsolete and abandoned, and those wells can be reused for CO2 storage. And the CO2 storage is a critical component of a global initiative of CCUS. CCUS stands for carbon capture, utilization, and storage. And the main purpose of CO2 storage is to reduce the excessive CO2 in the atmosphere. And this is a very challenging problem because we want to store CO2 underground for permanently, for a very long time. And here are the global activities on CO2 storage. This is a United Nations charts. And a lot of activities around the globe. And here is the Halliburton's capabilities in CO2 storage. We have a track record of delivered CO2 storage solution, and we also provide CO2 rated well construction design. And here are the Halliburton's CO2 storage projects around the world. And the star represent our own project. Triangles are the projects we are involved, and the squares are the technological studies we are engaged. Lastly, recycle. When you consume fossil fuel, one of the waste generated is carbon dioxide. And actually we can recycle it, or we can, capture it and store it underground, right? So here I'm going to talk a little bit about recycle carbon dioxide to help us in the oil production. So this is basically a heavy oil reservoir, and the oil is very hard to come out of the underground. So what we can do is we can pump CO2 into the reservoir. And once the CO2 gets into certain depths, it becomes supercritical. So it's more like a liquid. And the CO2 will mix with the heavy oil, reduce the heavy oil's viscosity, and increase its mobility. So that's how we can enhance oil recovery. And with that, so we have a more efficiency in producing the oil, and we also use the waste from our fossil fuel consumptions. And once this reservoir is depleted, then we can keep the CO2 there. Then this depleted well becomes a storage site. So that's what we do. Three simple examples how we reduce our material and energy consumptions, reuse obsolete wells for CO2 storage, and recycle CO2 in our production. So right now, in summary, we have too much CO2 in the atmosphere. Our industry as a whole have a solution. Working with the rest of the society, we have a solution deep under the ground. That is, we have a solution to capture and store carbon dioxide and reduce CO2 concentration in the atmosphere. So that's a quick presentation, and thank you for your attention, and I'm open to questions.
Thank you very much.